Hello, today we're going to talk about applications of linear systems. Applications of linear systems is just a fancy way of saying doing systems with word problems. So I'm going to show you how to do these. There's two ways you're going to break down a word problem. There's two things you're looking for. Either both equations are going to look something like this, or they'll both look something like this. Alright, so being slope intercept form, I call it standard form. One way, but you're looking for a system, so you're looking for two equations. You'll have a total in there somewhere, you'll have some $5 per day, 5 minutes per hour, something like that. That doesn't make sense, 5 miles per hour. But they're gonna be one of these two formats. The way I always do systems is I just assume they're gonna be written like this. So that is how I break them down, and I'm gonna show you how to do that. So with my first example, we'll say the sum of two numbers is 1212. The difference of those numbers is 518. All right, so I'm looking for two equations here. How I break this down is very simple. Since I just assume it's going to be in this format, I always do x, y, total. And then I say this is my first scenario and this is my second scenario. And this is how I do it. And if you want to make it into a chart, you can draw lines, whatever you want. But this is just basically a table. Then I'm just filling in information as I go along. So the sum of two numbers is 1212. So I have one of my totals is 1212. I try to look for my totals first to see what I'm looking for. So in this case, I can call this one the sum. All right, the difference in those numbers, I can call my second scenario the difference. Now a lot of times you'll have names like Jack, Jill, stuff like that. So the difference of these numbers is 518. So when I'm talking about sum, I'm talking about adding, difference, subtracting. Now I just have to fill in the rest of the blanks. Since I don't know what these numbers are, and there's no per or anything, all I have to do is just put my variables in. So if I add these two numbers together, I'm gonna get 1212. If I subtract these numbers, I'm gonna get 518. All right, so now we solve. Since this is already set up for elimination, that's what I'm gonna do. So x plus y equals 1212, and x minus y equals 518. You can do whatever method you want. This is usually not the method I use, but if it's set up this simple for it, that's fine. So 1x plus 1x gives me 2x, y minus y equals 0. That gives me 10, 3, 7, 1. Yeah, sounds good. So 2x equals 1730 divided by 2 divided by 2. So x equals 865. I guess that's it. I really don't know. So let's see. So if my x equals 865, let's see if my y works. So once I have my x, I find my y. So I'm gonna plug it into x plus y equals 1212. So 8 plus y equals, 865 plus y equals 1212. Minus 865, minus 865. So 1212 minus 865 gives me 0, 12, 7, 1, 10, 4, 0, 1, 11, 347. So y equals 347. All right, since I know that's what I got here, let me check right here. So 865 minus 347 should give me 518. So 5, 10, 8, 7, oops, should have done that, 1, 518, so check. So my numbers here are 347 565. Those are the two numbers. Their sum gives me the 1212. Their difference gives me 518. All right, here's our next example. So the length of a rectangle is 4 times the width. The perimeter is 45 inches. So I break this down again. X, Y, total. Scenario 1, scenario 2. Now, does this always work, what I'm doing? No. But for the most part, it'll help me out. So the length of a rectangle is 4 times the width. That doesn't help. I'm looking for my totals first. So I do have a total, and that's 45. All right, so every once in a while you're gonna come, well, not once in a while, quite often you're gonna come across problems like this where you have to go back to old information. So you need to know how to find the perimeter. So the perimeter is 2 times the length plus 2 times the width equals the perimeter. So 2L plus 2W equals that. I'm actually gonna switch these, L and W. So that's my first equation. All right, now I need to find my second one. The length of a rectangle is 4 times the width. All right, so this one's a little bit different. It doesn't fit into my mold here. It fits into this mold up here more. That's all right though. So if I know 4 times my width, let's see. So I know my length, and then if I break this down, I have is equals 4W. All right, I still have my total of 4W because that's how you read. Whenever you say is, the next thing's gonna be your total. So here's my 2 equations, even though it doesn't look exactly like that. And then I solve from here. So 2L plus 2W equals 45, and then L equals 4W. So I'm gonna do substitution for this one because it just fits the mold. So 2 times 4W plus 2W equals 45. 8W plus 2W, 10W equals 45. W equals 45. Alright, so now I have the W, I have to find the L. So L equals 4 times 4.5. L equals 18. Woohoo! So it's 18, 4.5 is my answer. Just do whatever method you want. The way I usually would do this is I would actually solve for L here just equal to each other. That's just the way I like to do it, but that's how it's set up. All right, here's our next one. Boxes. Set it up the same way. X, Y, total. Scenario 1. Equation 1, equation 2. So I have small boxes, which are DVDs, which I don't really know if anybody uses anymore. So much streaming. Big boxes are the gaming devices. So it says 3 big boxes and 1 box of DVDs weighs 48 pounds. So there's my first total. Now before I continue on, there's many ways to break down word problems. This is just how I do it. I set up my little table and I look for my totals first so I understand what it is. So this is just going to be scenario 1 for me. This will just be scenario 2 for this simple one. So this whole first part is just 1, and then the second part starts right here. So 3 boxes, 5 boxes weigh 72 pounds. So I have my totals. I just need to know what I have to combine together to get to those totals. So big boxes and small boxes. So I'll switch these to B, or I'll do small and big. So 3 big boxes, 3 big boxes and 1 small box equals 48 pounds. Now I have 3 big boxes again, plus 5 small boxes equals 72 pounds. How much does each box weigh? Alrighty, now let's do our little fun time equation. So S plus 3B equals 48, and 5S plus 3B equals 72. Alright, I'm going to use elimination. I'm going to multiply this bottom part by -1, so that I get negative 3B. Bring down the top, so S plus 3B. And now I combine. So it gives me negative 4S equals negative 24. Yeah, 24 divided by -4 divided by -4. S equals 6. So every small box equals 6 pounds. Now I have to find out the big box. Take that and I plug it back into my top equation just because it makes it it's the easiest one. So S plus 3B equals 48. Minus 6, 3B equals 42. Divide by 3, divide by 3, B equals 14. Woohoo, I did it right. 14 pounds. And there you go, that's how you do it. Set it up, and did whatever process you wanted to. If you want to do substitution, you can move 3B over and substitute, do whatever you want. Alright, last one. And I kind of simplified these word problems down a little bit. It would say how much does a shirt and how much does a tie cost? But I just thought it'd be better just keep it simplified. 1, 2. So I have two equations, scenario 1 and 2. So 3 shirts and 5 ties cost $60. 2 shirts and 3 ties cost $39. So 3x plus 5y. I can call this shirts if I want, and call this ties. And there we go. Because it's $3 per shirt, or 3 shirts, and this is your price right here. So 3 times whatever the price is, 64. 5 times whatever the price is, 3 times whatever the price is, so on and so forth. You get your 2 equations. So 3x plus 5y equals 60. This isn't the most fun problem in the world. I'll give you a fraction. I don't want to deal with fractions. Let's do... I'm going to do elimination. I'm going to multiply the bottom by -3 and the top by 2. So that will give me 6x plus 10y equals 120. That gives me negative 6x minus 9y equals negative 117. That gives me y equals, that's simple, 3. So take 3, substitute back in, I get, do the top one because I don't like the number 39. Doesn't matter which one you do. So x equals 15. So I'm going to check this 15 and a 3 with my second equation. So 2 times 15 plus 3 times 3 should give me 39. Give me 30 plus 9 was 39. Check. So it's $15 for a shirt and $3 for a tie. And there you go. That's how you solve it. All right, this has been Applications of Linear Systems. Hope it helped.